Bismillah ar-Rahman ar-Rahim. This is Dr. Ahmad Al Faris. Today we're going to answer Unit 2, Edexcel, May, June 2021. Okay. Now, as usual, we are not going to answer the multiple choice questions. We are going to go to answer the starting from question 11. Okay. Now, I want from you now today to cooperate with me to answer the whole questions together. Okay. We have enough time for today, okay? And I want from you to send me on the chat, okay, what do you think about each question, okay? For example, in question 11, what do we have? Two copper wires, W, okay, and Z. So both of them, they are copper, okay? W and Z are joined, okay, as shown. They are joined in series, where W has twice diameter than Z. That means the cross-section area for W is equal 4 times the cross-section area for whom? For Z. Again, why the cross-section area for W is 4 times? Who can tell me? Yes, why is this? Because we know that when they say that exactly, the area equal pi r square, and that means pi diameter square divided by 4. So that means when we say that the diameter is twice, that means I'm saying 2 square, which is what, 4. Thank you, Hamza. Okay, so why Z and Z are connected in series, okay, with the cell and a resistor. So this is the cell, this is the resistor, and this is the two wires as shown. State the purpose of the resistor in the circuit. Who can tell me why we connect resistors in the circuit? One of the answers, Hamza sent, yes, correct answer. Another answer? Now, actually, if we connect it to a variable resistor, we can vary the potential difference. But here we connect it to what? A resistor, a fixed resistor. So we can't vary the current, but we can minimize the current to reduce what? Heating effect. So the idea is to avoid the heating effect, to reduce the current and avoid heating effect, to reduce the current and reduces the heating effect. The heating effect. Can you please send the exam on the group? Okay, now Hamza, can you send the exam on the group if you please? Yes, thank you, Hamza. Okay. I really appreciate it, Hamza, if you send it. Thank you. Hamza sent the exam. And send the mark scheme also. Okay. Part B, what do they ask here? The current I in the what? In the conductor is given by the formula I equal navy, as we know it, or NQVA, okay? Complete the following table, which, okay, shows the ratio quantities for the wires Z and W and Z, okay? The first row, okay, has been completed as you know, okay? Now, number of free electrons in wire W over number of free electrons in wire Z, it's the same since both are made by same material. So 1 over 1, which is 1. Current over current. Now, since they are connected in series, what do you think that the current ratio it will be? Exactly. Thank you, Hamza. It will be also 1. Okay, both wires are connected in what? In series. So when they are connected in series, okay, they have same current, to have same current. Okay. Next, what they ask here, the drift velocity for W over the drift velocity of what Z. Now we know that the cross-section area for W is 4 times the cross-section area for Z. The cross-section area for W is equal 4 times what the cross-section area for what? For Z. Now we know that the drift velocity, it's inversely proportional with what? With the cross-section area from this formula. Okay, that means the drift velocity for W, it will be what? More or less? It will be more than for Z by how many times? So the answer, it will be 1 over 4. Okay, because it's inversely proportional. So the ratio, it will be 1 over 4, since what? V is what? Inversely square with the diameter. I have a problem with the pen today. I can't write it correctly. Since V is inversely proportional, okay, inversely square with what? With the diameter. Okay, good. Any question here? Okay. Is there any question here? Is it clear? Okay, let's move on to next question. Question 12. The diagram shows the resistance of what? The resistor of resistance of 270 ohm connected to a battery of EMF 9 volt. Okay, 9 volt. The battery has an internal resistance of what? 15 ohm. Okay, what do we have? We have a battery, we have a voltmeter, we have a switch, okay, and we have a resistor 270, and this is it. Explain why the reading of the voltmeter is less than what? The 9 volt, okay, when the switch is closed. When the switch is closed, that means there will be a current. So when there is a current, what's happening here? Thank you, Ammar. The EMF is equal to the voltage plus the what? Plus or minus? Yes, it's voltage plus, okay, or the reading of the voltmeter equal the EMF minus IR. So because we know that, okay, because we know that the voltage or the potential difference is what we can say. It's the energy per unit charge, okay? That means there's some energy dissipated through what? The battery, as, okay, so this energy is transferred to the circuit. Potential difference is the amount of energy needed for each 1 coulomb charge to pass between 2 points So due to EMF equal V minus IR, okay, less potential difference and less energy is sent to the circuit due to some energy is dissipated through what? Through the battery, or inside the battery. Dissipated through the battery. As I told you, I have a problem with the pen. It's not clear reading. My handwriting is not good. Okay, so I'm sorry for this. There's a problem with the pen. I don't know what's the problem. Okay. Any questions so far? Thank you, Hamza, for your answer. Okay. Next part, part B. Calculate the reading of the voltmeter, okay, when the switch is what? Is closed. Now, when the switch is closed, we have to know how much is the what? Yes, since the internal resistance is 15 ohm, so we have to know how much is the current here. So we know that the current total in the circuit is equal to 70 plus 15. This is the first step. Then second step, we know that the current in the circuit, the total current, equal the EMF of the circuit divided by the total resistance, okay, which is 9 divided by 285, okay, ampere. The third step, okay, I'm going to take the reading of what? Of the voltmeter here, and the reading of the voltmeter, which is equal I multiplied by R, which is the 25. So the answer that we got it here, which is 9 divided by 285 multiplied by 270, okay, my answer, it will be 8.53 volt, okay? Good. Any question? Is it clear so far? Okay, well, one of the answers why we did this 3 steps. Okay, you can do whatever you want. Okay, you can do it in one step by using the formula, okay, that I just write it down here. Okay, you can use it. Or you can use the long formula to find out the whole answer, as Hamza said. Thank you, Hamza. Yes. Yeah, thank you. Teacher, why in part A we should mention the potential difference? Okay, because the voltmeter measures potential difference, yes. Why did you write E in the second step and V in the third step? Now, the total voltage, okay, for the whole circuit is what? Is E, okay? Or you can write V total, the V actual voltage come out from the battery, not the reading of the voltmeter. So this reading is the reading of what? Of the voltmeter, which is equal I times R. Did I answer your question? Okay, you are welcome. Let's move on. Okay, part C. What do you have? The switch remains closed and 12 coulombs of charge pass through the battery. Calculate the decrease of the chemical energy stored in the battery. Now we have to know that the definition of the voltage is what? Energy per charge, right? So the voltage for the battery, okay, is the definition of the amount of energy given or used for what? For the charge. If we know how much is the energy, we need to know to do cross multiplication. So energy equal voltage multiplied by what? Charge, which is 9, the EMF, okay? 9, this one is the EMF. So 9 multiplied by 12, and the answer will be 108 joules. 108 joules. Good. Is it clear so far? Any question? Okay. Now let's move on to what? Question 13. The refractive index of glass varies with the color of light, okay? The refractive index for red light, it's 1.513, and the refractive index of glass for violet is 1.532. Is there an equation for chemical energy? Chemical energy by itself? No. But you are going to study it later on in chemistry or in physics A2. But here, because we are talking about the amount of energy stored in the battery. So energy by doing cross multiplication equal the potential difference multiplied by the charge, or energy equal VIT as current. They ask about how much electrical energy that lost, okay, decreased by the energy store. So for example, if the energy stored was 20,000, okay, how much remains? It will be 20,000 minus 108. They didn't ask about this. They ask about how much energy is decreased, okay? Did I answer your question, Hamza? Muhammad? Muhammad, is it clear? Okay, you are welcome. So we have the red here, and we have the violet, and the refractive index for violet is more than the refractive index for red, as you know. And I told you about Messi and Cristiano Ronaldo. Both are fast. Okay, Cristiano Ronaldo, since he is long, he's tall, okay, his longest step, okay, long wavelength. That means it takes long time to deviate or to change direction. That's why his refractive index for red, it's less than the refractive index for violet or for blue, like Barcelona or Paris Saint-Germain. So that's why Messi, who's short, his steps or wavelength is shorter, he can deviate more. Than why the refractive index for him is what is more. Okay, good. Okay, A ray of light, okay, is incident on side AB like this, okay, of rectangular glass block. As shown, we have an angle of incident of 54.00. So there's 2 decimal places, 4 significant figures. We have to be careful. Here we have the same thing, 4 significant figures, okay, because there's a small difference between red and violet. That's why they put all these significant figures here, okay? Okay, the red light and the violet light of incident arrive at at different points on the side CD, okay? Determine the distance between the sides, okay, at this. Now, they give us how much is the distance. For example, we know that, I told you that Cristiano Ronaldo, he will change his direction a little bit like this, for example, the red one, okay, Manchester United, but Barcelona or Paris Saint-Germain, the blue or the violet one, he will deviate with what? More angle, like this, for example, okay? It's not to scale. Now, as you can see here, this angle of refraction for violet, okay, RV, okay, is not as the same as for the red, Cristiano Ronaldo, R, okay? So the RV, it's smaller. So the opposite, okay, for each one of them here, the opposite is different, okay? The distance which is the opposite, okay, by using the formula sine or tan, or because I have this side, which is this side, the normal, it's not the same as this one. They didn't ask about how much of that or this. They ask about the difference, this one. They ask about this difference. So I have to find how much is the deviation, okay, for the red and the deviation for, okay, so this is the deviation for the violet, okay, and this is the deviation for the red, okay, and they ask about the difference between these two, okay. I will call it, for example, D or delta D, okay, delta D. They ask about this distance, how far it is, okay. So that's why it takes 5 marks. So what do we need to find out? We need to find how much is the refracted and how much is the refracted angle for each one of them. Okay, so we are going to use the same formula twice. Okay, sine R, Ni sine R is equal to Nr sine R. I'll do the red one with the red, then the violet one with the violet, then I will do the difference between them. So Ni, okay, this is for red, okay? Ni sine I equal what? Nr what? Sine R. Okay, sine what? R. Now, what do we have here? Ni, which is 1 for air, sine 54 equal Nr for red, which is 1.513, okay? Sine what? Sine R. So by using the calculator, okay, R, it will be how much? 32.32 degrees, okay? But for the violet now here, okay, I'll do the same thing. Ni sine I equal Nr sine R. So Ni, which is 1, sine the same angle, 54, equal Nr, which is 1.532, 1.532, sine what? R. And R for the violet, okay, which is equal, by using calculator, how much? 31.88 degrees. Yes, thank you. Now, this is the first step. Okay, now I'm going to continue here to find how much is the distance for the red, okay, by using tan, okay? So we know that tan theta equal opposite over what? Over adjacent. I'm going to use it once for the red and once for what? For the violet. So tan 32.32 equal the opposite, which is dr, okay, divided by the what? The adjacent, which is 6.4. It doesn't matter to keep, I can keep it in centimeter. And by doing cross multiplication, the distance that deviates by red color, it will be 4.049 centimeter. And for the violet color, I'll do the same thing. Tan for 31.88 degrees, okay, equal the deviation or the distance change for the opposite for the violet, okay, divided by the distance, which is the same, 4.6. So by doing cross multiplication, for the violet, it will be how much? It will be 3.981 what? Centimeter. Now, what do we need to find? We need to find the difference. To ask, determine the distance between these 2 points, this point and this point. Now, delta what? D is equal to dr minus what? dv, which is equal to 4.049 minus 3.981, and the answer, it will be 0.068 what? Centimeter. It's a long question, yes. That's why it's 5 marks, but it's not that hard, is it? It is fine if we give n meter. Yes, of course, it's to be the same answer if we convert it into meters. It's not necessary to convert it into meters, okay? Take screenshot. Let's move on. Okay. Part B. White light, okay, is instant the boundary between the glass and air, from glass to air, from slow to fast, as shown. Explain what happens to the red and what happens to the violet, okay? Red light when it's meeting the boundary, okay? Your answer should include what? Calculations. Now, since we are talking from glass to air, that means from slow to fast, okay? That means maybe it reach or exceed the critical angle. So it's this angle, 41 degrees, maybe less or more than the critical angle for whom? For the violet and for what? For the red. So I have to find how much is the critical angle for both of them. So critical angle equal what? Sine inverse for n of air divided by n for glass, okay? And I'm going to use this again twice, once for red, okay, and once for violet, and I'm going to tell them what will happen for each one. So critical angle for red light equal what? Sine inverse for 1 over the refractive index for the red, okay, which is 1.513, okay, 1.513, and the angle is how much? The angle is Who has a calculator? Okay, it's 41.4 degrees. And for the violet, yes, thank you, Hamza. For the violet, yes, okay, it will be the same thing, but it has a different refractive index. So 1 over 1.532. And by using calculator, the angle is what? It's 40.7 what degrees. Now, as you can see now, one has a critical angle more, and one has a critical angle less. So that means the critical angle is more than this. So that means the red light will refract in the air. Okay, red light will what? Will refract. Refract to what? To the air. Okay, since its critical angle is more than what? More than 41 degrees. But here, the other one, okay, the violet, what happened to it? The violet light will what? Will have total internal reflection, or have total internal reflection, okay, since its critical angle less than what? 41 degrees. Okay? Any question? Is it clear? واضح؟ أمور تمام؟ Okay, let's move on to next part. What do we have next part here? Okay. A student connected a circuit shown. Okay, the battery has negligible internal resistance, 9 volt battery. We have a voltmeter and we have a thermistor. The voltmeter is connected across a fixed resistor, 11.5 ohm, and we have what? A thermistor connected in series with this resistor. The graph shows how the resistance of the thermistor varies with what? With the temperature. So as the temperature decreases, its resistance what? As the temperature increases, its resistance what? Decreases. Okay. Yes, thank you. A, the reading of the voltmeter is 3.42 volt. Determine the temperature. Now again, we have to know that the 9 volt, okay, since they are connected in series, is divided between both of them since they are connected in series. So when they say that, the voltage here is 3.42, so what I'm going to say here, I'm going to use the formula, okay, V total equal what? V, okay, for the resistor plus the V for the thermistor, okay? So V total, or V from the battery, okay, which is 9, equal 3.42 plus V, okay, of the thermistor. We don't know how much it is. So by subtracting these values, okay, we can find out that the voltage here is equal to 5.58 volt. We are going to use the graph. Okay, I'm sorry for my handwriting. It's not like this, you know, my handwriting is good. Okay, I'm going to use the graph, okay, to search, okay, for this. Okay, I need to find the resistance. So, they give us the resistance, not the voltage. Okay, so I'm not going to do this. I'm sorry, my mistake. Okay, hold on. I need to find how much is the what? How much is the resistance to do this? So to find the resistance, I need to find the current. So V equal IR, I'll use it twice, okay? Once for the fixed resistor, V for resistor equal I multiplied by the resistor, which is how much it is. It's 11.5. 11.5 multiplied by I, okay, equal 3.42. So I can find the current, which is, yes, thank you, 0.297 ampere. This is the first step. Then I will do it again, okay, for the thermistor. So the voltage for the thermistor equal I multiplied by R for the thermistor. Okay, so V for the thermistor, which is 9 minus 3.42, which is 5.58. Okay, equal I 0.2297 multiplied by R. So R for the thermistor equal this divided by that. And the resistance of the thermistor equal 18.8. Thank you, Ammar. Thank you, Hamza. Okay, ohm. Then what I'm going to do, I'm going to find from the graph how much is the temperature. So 18.8. So this is 10, this is 20, this is 18, this is 18.8. So I will draw be like this. So the temperature will be approximately how much? How much is the temperature? Approximately, let's say 33. 33 is accepted, or 34? Yes, 33, I can say. 33 or 34 degrees Celsius. Good. Yes, from the graph here. Yes. 33, 34. There is range, I think, in the accepted answer in the mark scheme. Is it? Okay. Thank you, Hamza. This is part A. Part B. The students suggest that if the EMF of the battery is doubled, if the EMF of the battery is doubled, okay, the reading of the voltmeter, it will be what? Doubled, okay? Assess whether the student suggestion is correct or not. Now look here. By increasing the voltage, okay, of the battery, what will happen to the size of the current in the circuit? It will be more, right? Good. So by increasing the voltage of the battery, that means there will be more current through the circuit. So when there is more current in the circuit, does this cause heating effect? Of course it causes heating effect. So what happened to the temperature of the thermistor? The temperature of the thermistor increases. So as the temperature of the thermistor increases, what happened to the resistance of it? What happened to its resistance? It increases or decreases? Thank you, decreases. So as the resistance across the thermistor decreases, also the potential difference across the thermistor decreases. That makes the potential difference across the fixed resistor, what happened to it? Increases, since they are connected in what? In series, yes. So the reading of the voltmeter, which is across the resistor, the fixed resistor, what happened to it? It will be more. So his suggestion is what? The student's suggestion was not correct, right? Okay. If we look to the mark scheme, I think this is the mark scheme. If you look to the mark scheme, I think they mentioned the same idea that we have to mention. Look here. Where is it? Yes, it is here. Question 14, part B. Increasing EMF leads to have a greater current. Increase the current, give a higher temperature heating effect. The resistance of the thermistor will be decreased. So the proportion of the total voltage across the thermistor will be decreased. So the reading of the voltmeter, okay, will be more than double the student that is not correct. So if I'm going to write it down, what I'm going to say, as the potential difference is doubled, okay, there's higher as the EMF. Okay, the EMF of the battery or the potential difference of the battery. You can say whatever you want. Yes, you can say it in both ways. As the EMF, okay, is doubled, there is higher what? Higher current through the circuit. Which causes heating effect, which causes heating effect to increase the temperature of the thermistor. So its resistance decreases, and also the potential difference across it decreases, making the potential difference across the fixed resistor increases more than the double, increases more than the double. So the student is incorrect. So the student suggestion is incorrect. Good. Any question? Any suggestion for the answer? Do you think it's clear? Okay, let's move on to next question, question 15. Question 15, what do we have here? A student used two sources, A and B, of electromagnetic radiation to investigate the photoelectric effect. Radiation from A has photons of energy 2 electron volt, okay? The radiation of B has a wavelength of 280 nanometer, that means times 10 to the power of negative what? Negative 9. Show that this radiation has a photon energy is about 4.4 electron volt. Now, we know that the energy for any photon equal what? Planck constant multiplied by the frequency. Yes, thank you, Hamza. Thank you, Ammar. Both of you give me, hold on, Ammar. Yeah, okay, be careful. I'm not talking about kinetic energy here. Wait, hold on. Okay, so which is equal to what? Which is equal to Planck constant multiplied by speed of light divided by what? The wavelength, because I don't have the frequency, I have the wavelength. So I will substitute the values here, which is 6.63 times 10 to the power of negative 34, multiplied by the speed of light, which is 3 times 10 to the power of 8, divided by the wavelength, which is how much? 280 nanometer times 10 to the power of negative 9. And the answer, by using this formula, it will be how much? It will be 1.07. Okay, write it here. 1.07 times 10 to the power of what? 15 hertz. Now, this is in what? In joules. I'm sorry, in joules. And I want it in what? I'm sorry. Okay. This is what? 7.09 times 10 to the power of negative 19 joules. And I want it in what? In electron volts. So I'll divide it by 1.6 times 10 to the power of negative what? 19, which will be equal how much? 4.43 times 10, okay, electron volt, which is approximately 4.4. Okay? Yes, thank you, Hamza. So that's what we did here, okay? We find how much the energy for, and they give it to us, okay? Why they give it to us? Since they give us this value, that means I'm going to use it what? In the next parts of the question, okay? Next parts of the question, what they ask here. Part B, we have a star question, 6 marks. Part B, a student used the two sources of radiation, okay, to investigate the photoelectric effect of two different what? Metals, copper and zinc. So we have two sources, A and B has higher energy, okay, higher photoelectric, higher energy for each photon than what? A, okay, and we have two different metals, copper and zinc. What they ask, the following statement, okay, were made by the student. When the radiation of photo energy of 2.0 electron volts from source A, okay, is directed towards the either of the metals, okay, there's no electrons are released. No electrons are released, okay, even if the light intensity what has increased, okay, is increased. That's the first information. Then second paragraph, okay, when the radiation from photon, okay, energy of 4.4 electron volt from source B is directed towards the copper plate, no electrons, okay, from copper, no electrons are released. However, when the radiation directed to the zinc plate, electrons are released, okay? As what the intensity of radiation is increased, the electrons released, okay, has a greater what rate. So, okay, 6 marks here. I have to tell them that the work function for both of these what metals, it's greater than 2.0 electron volt. So the source A, which has photons of energy 2 electron volt, it's not sufficient enough to liberate electrons from the surface of each metal. So that means each metal has a work function greater than 2 electron volt. And also copper has a work function greater than what? 4.4, but not what? Zinc. Zinc has a work function between 4.4 and 2. And as we increase the light intensity here, we increase the rate of photons that reaches the surface, okay? And we don't increase the energy that for each photon by increasing the intensity. We increase the number of photons, the rate of number of photons reaches the surface every second. So that's why, okay, when we do that in the final step here, what's happening here? As the number of photons incident to the surface every second is higher, that means the liberated electrons that every second will come out, it will be what? Higher, because each one photon, it will interact with what? With one electron. One of the answers, Ammar said, copper has a higher threshold frequency than zinc. You can say that, or the energy for photon emitted, okay, each one photon emits 1 electron. Yes, thank you. Okay, let's go to the mark scheme and check what are the main ideas that we have to tell them here. Okay, as you can see here, what they mentioned. Frequency of source A is less than the threshold frequency of metal, or frequency of A is less than the frequency of B, or, okay, for copper, it has greater work function of zinc. Okay, this is an idea that we have it. Photons energy of source A is less than the work function of metal B. Okay, the photons of source B has less than work function of copper, but greater than what the work function of zinc. Well, the work function of zinc must be between, okay, these two values, okay? The intensity is linked to the number of photons per second, as we said, okay? Each one photon releases one electron, okay? So greater intensity leads to greater number of electrons and photons every 1 second. Now, how we can connect these ideas together to answer the question? Okay, one of the answers, light from Hamza Rahal, light consists of photons, and okay, each photon has energy, depends on its frequency. So energy for a photon equal HF. So energy of the photon is directly proportional to the frequency light, okay? And electrons will have all of this energy by one photon, since each one photon interact with one electron. And this cause, okay, the source has a frequency of light lower than the frequency, okay, from source A, yes, from for both of the metals. So electrons will not be released from the metal surface. So this means source A has energy for photon, okay, less than the work function for two metals, and no electrons, okay, will be released. يعني, okay, so I think that you get 3 out of 6 marks, okay? That's good. This is good. Thank you, Hamza. So let us rewrite the answer together, okay? And I'm going to start as, this is my start, yeah, Hamza. I know this is not full answer, yes. I'm going to, this is my starting, okay? I always says that light consists of photons, and each photon has energy depends on its frequency. So, yes, okay, thank you. Okay, I'm going to write this. This is my statement. Okay, light consists of photons, and each photon has energy depending on its frequency. And each photon interacts only with one electron. And if its energy is greater than the work function of the metal, the electron is released. The electron is released. Okay, this is what, this is the initial statement that you start talking about the photoelectric effect. So we are going to continue now. Source A has what? Has frequency, okay, less than the threshold frequency, of both metals. And also the photon energy is less than their work function. So come on, sorry. And by increasing its intensity the rate or the number of photons incident every second, every 1 second, increases not their energy, not their frequency, increases not their frequency. Okay. خش على الجد. So, but source B has what? Frequency greater than the threshold frequency of zinc but not for copper. Making the work function of zinc between 2.0 electron volt and 4.4 electron volt. But for copper, it is greater than 4.4 since electron volt, since no photoelectric effect happened. And by increasing the intensity, number of photons reaches the zinc surface every second, 1 second increases, so more electrons are released. I know I explained it a lot, okay, with more details that it needed, but okay, you can write, okay. Okay, I have a lot of answers that Hamid tell me, but what is the work function, Hamid? Work function is the minimum amount of energy needed to liberate an electron without having a kinetic energy from each metal. And each metal, each surface has minimum amount of energy to liberate electrons. Do you remember when I told you about the $500 that I needed to liberate myself from the one that in front of my threshold? Okay. Yes, this is the answer. Did I explain it? Okay. Hamza Continue the answer. Thank you, Hamza. And thus, what is the threshold frequency? Threshold frequency also, they will ask you about it. It's the minimum frequency needed from the photon to liberate what an electron from a metal surface, okay, without having kinetic energy. Okay, sir, do you think that it's a good idea to tackle the star question as the first thing in the exam? Yes, forget them. Don't answer the multiple choice question in the beginning, okay? Because you are excited, your adrenaline is high, okay? You maybe get nervous, okay? So don't waste your time by the multiple choice question. Start from question 11. Yes, this is my advice every time. Can we also explain since the no photoelectric effect happens for copper? Yes, we mentioned that, huh? I mentioned it. Hey. Happened for copper, yes, but for copper, it is greater than what 4.4 electron volt since there is no photoelectric effect. No, I was asking what it means. It means that why that there's the work function for copper is more than 4.4. Why? Because neither source A or source B, okay, make electrons come out from the what? From the copper. So that means it has greater work function. It needs more energy. You are welcome. We explained this lesson different ways many times. Okay, let's continue to question 16. Did you take screenshots? Are you done by them? Halas? Okay. Question 16. What do we have here? Question 16. When unpolarized light passes through a polarized filter, the light becomes plane polarized, okay? Explain the difference between unpolarized and plane polarized light, okay? One of the answers, Hamza, Rahal, the polarized light is the light that oscillates in one particle, okay, in one plane in which perpendicular to the direction of the wave propagation. But the unpolarized light, it oscillates in many planes. Thank you, Hamza. Yes, your answer is excellent. So we have to write the word oscillates, okay? That means the unpolarized light oscillates in many planes, okay? But the polarized light, okay, oscillate in one plane includes the direction of the wave travel, okay? Do you want me to write it down? Okay, I will write it down. I will write it down, and you can write it down in two different ways. We have two different ways to explain what's the meaning of polarized light, okay? Okay. Can we say polarized light, okay, move in one direction? No, it's not move, it's oscillate, vibrate, okay? Actually, the word oscillation is better than the word vibration. And don't write polarized with Z, write it with S, okay? Good? Okay, because we are studying British system, not American system. Okay? So let's say here, polarized light. Okay. Oscillate in one plane including the direction of the wave travel but unpolarized oscillates in many planes. Oscillate in many planes. Okay. So they count it. What do you mean they count it? So maybe it will lose a mark if I wrote for no. But they will make you a target. No, I'm just kidding. Okay. Now maybe an Indian person he's checking your exam. It doesn't matter if you are English or British system. Maybe I'll check your exam. No, I will not check the exam. Maybe 16 years ago, it was the last time I checked the exam. First time, last time. 16, 17 years ago. Okay, let's move on to, okay, Mister, is this 2 points? What do you mean by 2 points? No, okay, hold on. When you say that it oscillates in one plane, that's a mark, includes the direction of the wave travel, that's the second mark, but the unpolarized, okay, oscillates in many planes, okay, that's the third mark. That's why we get 3 marks. Good? So this first mark here, this is second mark here, and this is the third mark. Okay? Any question? Let's move on to part B. What do we have here? We have 2 Polaroid filters. Okay. The unpolarized light source is directed towards a screen. Okay. The intensity of the radiation, okay, measured by the screen, it was what? 1 watt per meter square. 2 polarized filters are placed between the light source and the screen. Okay. And initially they are at 0 degrees between each other. They are vertical, okay, between their planes, and for polarized light as shown. One of the polarized filter is rotated now. Now we rotate it as shown. Sketch the graph on, okay, to show how the intensity of light, okay, measured as the what screen varies from the rotation, okay, is rotated from 0 to what? To what? 90 degrees. Now, the light intensity, it's unpolarized, okay? So as it passes through these Polaroids, okay, the first one or the second one, or both of them, the light intensity is reduced to be less than 50%. Why? Because the unpolarized light oscillates up and down, sideways, okay, 45 degrees, 135 degrees. So that means, okay, as it passes, okay, all the horizontal components will cut out and only the vertical component will pass. So that means this one will pass and the component of this one also will pass and the component of this one will pass. So that means approximately less than 50% of the energy is reduced, okay? So as we rotate it, and we rotate it to be 90 degrees, okay? That means one is, okay, horizontal, and the other one behind it, it's still vertical, okay? There is no light pass both of them, okay? So the light was unpolarized. As it reached between them, it will become horizontally polarized. As it passed from the second one, there is nothing, okay? So that means the light intensity decreases. And the component of the decrease, okay, maybe it's linear, maybe it's not. It depends on the how accurate is what is the polarized crystal material, and how is the speed of what of rotation. We don't know how much is the speed. They didn't mention is it rotated at constant speed or not. Did they mention it? No, they didn't. So that means the light intensity decreases, let's say from 0.5, okay, not 1, okay, and it decreased to an angle of 90 degrees, this degree here. So I can say it's what, a straight line or curved a little bit until eventually it becomes what, 0, like this. Can we draw it a straight line? Yes, you can draw it a straight line. I think it's, they didn't mention, okay, can we curve it like this? Yes, we can. We curve it like this? Yes. But it's still, Shabab, it's still, Shabab and Sabay, of course, it's still decreased from what? Decreased from not 1, 0.5 or less. If you can write 0.4, 0.3, I think it's accepted. Okay, but let's make sure that it starts from 0.5 and eventually becomes to 0 at what? At 90 degrees, and we don't know the rate of rotation, it's fast or slow. So I don't know if I draw it like this or I draw it like this. I don't know. They didn't mention any information about this. Yes, so that's how we can answer the question. Teacher, I have a question. How the speed of rotation affect? Now, if they say that they rotated fast, then slowly, that means it will be like this, then slowly. You get the idea? Okay, so we don't know. So you can draw it like this. I think this is the accepted answer. Let's check the mark scheme. Hold on. Okay, what they ask, okay, number of numbers of line on both axes, okay. Then, I'm sorry, there's a problem with the pen here, okay. Then the single maximum at 0 degrees, okay, and minimum at 0 degrees, the light intensity from 0 to, okay, but not 0, okay. Hold on. Oh, yes, thank you, at the end page, okay. Look. 3 accepted marks if it's straight line. If it curved like this, 3 marks. If it curved like this, 3 marks. Okay, if it starts from 1, you lose a mark. Okay, if you didn't mention anything on the axes, you lose the 3 marks. If you say that 0.5, you get a mark, then you curve like this and go up. You what? That means you what will get another mark for the decreasing, but not the increasing. Okay, you lose the mark for getting 0. Okay, if you put 90 degrees, you get 1 mark. If you put curve and not reaching 0 also, okay, that means they are not completely crystallized polarized, okay? It's partially polarized filter. Also, you get 3 marks, okay? If you draw it a straight line, okay, like this, going up, but you mention 0.5 and 90 degrees, you will get 1 mark. Okay, if you mention 90 degrees and it changes, you will get 1 mark. If you mention 90 degrees without mentioning the axis here, you'll get nothing. If you start from 90 and you start at a certain point like this, okay, I don't think a clever student will do this mistake that the light intensity increases. The light intensity decreases, we know this. So most of the students will draw the first 8 answers, okay? The first 8 answers. Now, one of the questions, why does we have to be at 0.5? Not necessarily 0.5, less than 0.5, but 0.5 is accepted. I explained why. Why? Let's go back to my picture. I said here, when I explain it, that the unpolarized light, it's oscillating in all planes. As it passes through one or both Polaroids, okay, this one will cut out, this one will cut out, that will absorb it. This one has 2 components, one horizontal and one vertical. The one is horizontal, it will cut out. This one is the same thing, it will cut out. So eventually, most of these are cut out, most of these are cut out, okay? What's left, it's the component, vertical component, up or down, which is 50% or less. If you have polarized light, sunglasses, okay, and you put it okay in front of your eyes, you'll see that the light intensity reduced much more than 50%. I remember my student, I show them my glasses, right, my students? When you wear them, the light intensity reduced more than 50%. It will be very dark, right? Hamza, remember this. Okay. So let's move on to part C of this question. Also, I remember that in the school, I show you this. I bring 2 Polaroids and I put crystal material between them, and you saw that they change their colors from, okay? There's colors here, rainbow colors, okay? What they ask here in part C. The polarization can be used to identify somewhat material under stress, if there's weak points to start to break from it or not. Placing the material under what stress causing the plane polarized, okay, of the light passing through the material to be rotated. Okay, the angle of rotation of the plane polarized, instead of being like this, it will rotate a little bit. And each color, orange, red, orange, green, blue, indigo, it will rotate with different colors. That's why it looks rainbow colors. Okay, so actually, if they print this page, this color of rainbow colors, it will not be black and white. I will show you how it looks like. Hold on. Okay. Okay. Stress, strain. Okay. Plastic. Polarization. Okay. Yes, it looks like this. I remember Muhammad Hamid sent us a picture like this. Do you remember this one? Okay. This is a meter rule. You can see. Okay. Let me show you this. Okay. This is another one. Here's the cover of the photon. This is a metal, sorry, plastic spoon, how it looks like, these colors, okay? Also this one, okay, a CD drive, okay, show us how, where the stress strain analysis, where are the weak points, and how much does it rotate. This one also for a meter ruler, or set square actually. Okay, is it clear? Any question here? Okay, what they ask here, let's continue. So the greater the stress, the greater the rotation of the plane, okay, of the polarization of the light. A piece of transparent material under stress is positioned between two polarizing filters, okay? They are at 90 degrees. That's why there's no color here. It's dark, 90 degrees. So they cut out all the color, okay? Between the plane polarized themselves, okay? Between the two polarized, okay? Explain how this photograph can be used to identify the areas of the material where what different amount of stress it is. Now, we know that, yes, one of the answers from Hamza, the two polarizing filters are perpendicular to each other. So when the stress is applied, more rotation to the plane polarized light occurs, so that greater curve will appear as it passes from the second polarized. Bravo. Another answer. Another answer. Okay. If we go back to the mark scheme, this is question 16C. Okay, look what they ask here, what they tell us, sorry. They say that, okay, polarized filters at 90 degrees to each other that does not allow light to pass through. That's the first mark. Rotating the plane polarization, okay, due to stress allow what light to pass, okay? So darker areas represent less stress, okay? Or brighter areas represent what? Greater what? Stress, because they didn't show us colors here. They show us bright areas and dark areas, okay? Actually, they are colored, okay, as I show it to you. So if I want to write the answer here, no light can pass from the, no light can pass, okay, hold on. No light can pass through the two 90 degrees filters, since they absorb all of light energy, or of, sorry, light energy. Continue. But whenever there's more stress area, so there's more rotation of the plane polarized light, plane polarized light, polarized light. So it appears to be brighter. Good. Is it clear? Okay. Let's move on to question 17. Question 17, it's similar to one of the year's question. Actually, they bring the same idea, exactly the same idea. What they ask here, one of the questions. Yes, it's October 2019. Yes, thank you, Hamza. Yes. What they ask, a student used the apparatus shown in the photograph here to determine the speed of sound in air, okay? We have two beam oscilloscope. As you can see, there's one oscilloscope here and one oscilloscope there. So it's two beam oscilloscope. It's seen here, okay? And we have a signal generator, and this is a speaker, okay? And there is a microphone, and they measure the distance, okay, for the sound as it come out and reach here, okay? Now, what they said here, they assume that when they give you these few lines here in the Edexcel, okay, the Pearson system, they assume that you understand everything about this topic, okay, and this information. They can, you are now an expert of how we can measure the speed of sound or whatever the question it is. The student switches on the signal generator. The oscilloscope shows one of the trace of the signal generator, okay, and the other trace of the microphone. Initially, the peaks of the trace were directly above what the trough of each other, as shown in this figure. You can see that the crest, okay, it's with the trough, and the trough is with the crest. So what I can say about these, are they in phase or they are antiphase? Exactly, they are antiphase, yes. So what they ask here, the horizontal axis of the oscilloscope screen represent time. This axis, horizontal, represent time. The number of the number of milliseconds per divisions, okay, on the horizontal scale is what is known. So each one of them, each one of these tell us how many milliseconds, okay, in each division. So I can find the I can find the period, okay, the time from here to here, okay. How many waves you can see here from the beginning here to the end here? I can see two waves, one, two approximately. So by knowing the number of waves and by knowing how long is the time for each division, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I can find how much is the time for one oscillation, which is the period. Okay, what they ask. Explain how the apparatus shows in the photograph could be used to determine the speed of sound in air. Now, ideas. If I want to find the speed of sound in air, what do I need? Okay, I need to find distance and time, of course. Okay, fine. I don't have distance and time. The distance here, it's not distance, it represents a wavelength, and the time here represents period, or I can say that the speed equal frequency times wavelength, right? I have a huge answer now is sent. Okay. Measure the distance between the microphone and the loudspeaker by using a meter rule to move the microphone wave away until two waves are antiphase through the crest and it's not crest, it's the beak, okay? It's not crest, we can say compression and refraction, no problem. And then measure the new distance to find the wavelength, okay, by subtracting them to each other, okay? Then we can count the divisions to find how long is the time. Then we can say that speed equal wavelength divided by period, okay, which is the time for each one oscillation. Thank you, Hamza. You give me a perfect answer. Amazing, thank you. So 4 marks or 5 marks, 5 marks question here. Okay, what Hamza tell us, it's a unique answer, okay? Because whenever we move the microphone, okay, until what will happen here? Whenever we move the microphone, this one, okay, this one for the signal generator, because the amplitude is higher, this one will change. Maybe it will move like this, a little bit to the right or a little bit to the left, okay? But the frequency remains the same. So maybe it will be like this. So I keep moving it until I get the same trace, the same picture again. And I measure the distance from where I started to where I finish. This distance tell me how much is the wavelength, as Hamza said. Okay, and this distance is the wavelength. I will measure it by meter rule, and if I measure several distances, I'll be and divide by the number of wavelengths, I'll be more accurate to measure how much is the wavelength for each. Okay, once. Okay, And also, if I know how long is the time or the period by counting the divisions here, they give it to us, and we have two waves, okay, I can find how much is the period. So if I know the period, I can find the frequency or keep it period, okay? If I know the wavelength and I multiply both of them, I can figure it out how much is the speed of sound in air by doing this experiment. So if we go back to the mark scheme and we look here, what do we have? Measure the position of the microphone, okay, or measure the distance of the microphone from the speaker. Move the microphone gradually until what crest, okay, or peak, reach what aligned again, okay, with the same position here, okay. Measure this position, okay, until the traces are the same, antiphase again. This distance is what is, it's moved by the microphone, it's what is the wavelength. Okay, then we have to tell them what, how can we find the period, okay? For example, the time is approximately 5x. That means, I don't know what's this. Time period, okay, it's approximately, oh, okay, I get the idea. So multiply the wavelength by 1 over period, okay? Do not award a mark for using F frequency. If I mention frequency instead of period, I say the frequency is the inverse of the period, then I use this formula. That means I'm not correct. I am correct, of course. I am accurate, okay? I don't follow the mark scheme, but it doesn't matter, right? Okay, so let's go back to the question here. Okay, what I'm going to say, measure the distance from the microphone to the speaker by the ruler or the meter rule. Then move hold on. Then move the microphone slowly, okay, away or towards, doesn't matter, away from the speaker until the traces have the same shape as the picture or as the figure to be antiphase and measure the new distance subtract the distances, subtract the distances which is equal to the wavelength of this sound. Use the timer on the scale to find out the period of this sound by counting the divisions for one wave speed of sound equal wavelength over period. Take a screenshot. This is the first point, first paragraph. This is the second point, second paragraph. And this is the third point. Is it also part of Unit 3? Yes, but in Unit 3, they don't ask you to do how we can do the experiment in this way. In Unit 3, they ask different ways of, okay, they give you these ideas and they ask about how to be more accurate, what is the distance, okay, how much is the percentage uncertainty, something like this. They ask about what practical problems, okay, and how we, what the issues that we have when we do the experiment itself. Like resolution. Yes, thank you, Hamza. Yes, for example, in Unit 3, if I said I'll not do it once, I will make several traces and find the wavelength divided by the total distance by number of the traces, okay, that I get. And the same thing for the period. I measure the total time divided by what the length of how many waves do I have to find the period, the time for each one wave. That's how we paper Unit 3, they bring questions about. Good. Okay, let's move on to part B of this question. Okay, what they ask here in part B. Okay, a student changes the position of the microphone. Okay, the traces on the oscilloscope. Okay, the screen after and before changes the position of the microphone are shown in photograph 2 and 3. You can see they are antiphase and they are the antiphase here, but the amplitude here is much smaller because the microphone is away. But here the amplitude approximately they are similar. Explain what changes, okay, the student made to the position of the microphone between photograph 2 to photograph 3. It's obvious. The amplitude increases. That means the microphone is what? Closer, right? صح? Okay. So that's why the sound intensity or the displacement, the amplitude here is what is greater since the microphone is closer, so the sound energy, it will be louder, okay? Okay, since photograph 3 has higher amplitude, so the microphone is moved closer to the speaker since the intensity of sound decreases with distance. Sound decreases as the distance increases. Good. Okay, let's move on. to question 18. Question 18 about parallel and series. What do we have? The circuit diagram shows 3 identical resistors, okay, and 2 switches X and Y. The battery has negligible watt internal resistance. Each resistor consists of a wire of diameter. They give us the diameter 0.181 millimeter and a length, okay, 50 centimeter. At what room temperature? The resistivity is, okay, 1.1 times 10 to the -6 ohm meter. So they give us the diameter that we can find out the cross-section area from it. They give us the length, and they give us what? The resistivity. Show that the resistance of one wire, okay, at room temperature is what? 24. Yes, of course. Thank you, Hamza. We are going to use the formula resistance equal what? Rho L over A, which is equal to what? Rho, which is 1.1 times 10 to the power of -6, multiplied by the length, which is 0.55. I converted from being centimeter to meter, divided by what? By the area, and the area we know that it's pi, the diameter, which divide by 2 to get pi r squared, so 0.181 times 10 to the power of -3. I converted from millimeter to meter, divided by 2, all what? Square, okay? And by using the calculator, it will be how much? 23.5 ohms. Okay? Good? Okay. Part B. What do we have here? In part B, okay, they give us, a student suggests that the maximum power output from the resistors in this circuit will be greater than how much? 12 watt. Assess whether the user suggestion is correct or not. The user suggests that the maximum power output, okay, from the resistors, all the resistors, okay, in this circuit will be greater than 12 watts. Okay, now what do we need to do? Look here to the circuit again. When they ask about the maximum power, okay, that means they ask about maximum current. So the maximum current, I need to close both the switches to get what? Maximum current. Because when I have, okay, for example, this switch is closed only, that means the current will pass through these 2 resistors only. And because there are 2 resistors, that means the current, it will be less. Okay, now when I close this switch Y, that means the current will be more because I have one resistance. But since I close both the switches, that means the current will be, for example, this is 2I and this will be I. Why 2I? Because twice current, because there is one resistor, but here 1I, okay, because there is 2 resistors, okay? So that means the total current that come out from the circuit, it doesn't matter from where the current, direction of the current, okay? Okay, it will be what? It will be 3I, okay? And we need to find how much is the maximum power that come out. That means I will I will find it out, okay, by closing both switches, and I know how much is the resistance. Now that's why they give it to us, okay? I will find out how much is the total watt resistance. Now, what do we have? We have resistor in series, and we have total resistance in parallel. So resistor in series is 23.5 multiplied by 2 because they are connected in series, which is 47 ohms, okay? This is the first part. Second part, we need to find what? The total resistors, okay, combination, which is 47 times 23.5 over 47 plus 23.5, okay, and by using the calculator it will be 15.7 ohms, okay. Now what I'm going to do, okay, I'm finding the power, and the power, okay, it can be found by several ways. So I will use the power that has combined resistance here, so which is equal V squared divided by I, R total, or R combined. So the voltage here, which is 12 volt, yes, 12 volt square divided by 15.7. And by using calculator, it will be 9.2 watt. So he said that it will be greater than. So which is less than 12 watt. So his what? The student suggestion is incorrect. The suggestion is incorrect. Good. Yes, we can find the total current, and we can use another formula, for example, P equal IV, or you can use the formula P equal I square R. It doesn't matter. You can, okay. I'm trying to find the answer directly and quickly, and I don't want to lose any time during the exam. Okay. Tamam. Any question? Okay. Let's move on to part C. Switch X was open and switch Y was closed. So switch X was open and switch Y was closed. So I have only one resistor is connected now. Okay. So what they ask here. Calculate the number of conducting electrons passing through the resistor over what? A second immediately when after the switch. Okay. Now they ask about number of electrons. Now we know that Q equal what? N times E. Okay, N, the number of free electrons, times E is the charge, and we need to know how much is Q. Now Q, I can figure it out by knowing the current. So current equal what? The rate of a charge passing, Q over T. So what do I need first here? I need to find how much is I, the current. So to do this, I need to first step to find how much is the current, and that means V equal IR. So V, which is 12, equal I, which is unknown, multiplied by only one resistor, which is 23.5 or 24. So that means the current will be 12 divided by 23.5, which is approximately 0.511 or 512 or something like this. I don't know. Okay, ampere. This is the first step. Second step, okay, charge equal current times time. That means this value divided by 1 second, okay, multiplied by 1 second, they ask in 1 second, okay, so I keep it the same value. Third step, okay, N or Q equal N E, so that means N equal the value here that we find it, yes, thank you, Shabab, 0.511, divided by E, which is the charge for the charge for each one electron, which is 1.6 times 10 to the power of negative 19. And by using the calculator, the answer will be how much? 3.2 times 10 to the power of 18 electrons. So 3.2 times 10 to the power of 18 electrons. Tamam? Any question here? Is it clear? Okay, next. Double I. After switch Y had been closed for a few minutes, okay, the power dissipated by the resistor was decreased. Explain why. Now, few minutes, that means they take long time. So when there's long time and there's a current, and this current you can see it's 0.5 ampere approximately, which is high current, there will be heating effect. So since there is heating effect, that means the temperature of the resistors will increase. And as the temperature of the resistor increases, their what resistance increases. So as the resistance increases, that means the rate of flowing the current will be what? Will be low, okay? Or you can say, according to the formula, power equal V squared divided by R, since the voltage doesn't change, but the resistance increases, that means the power will what? Decrease, okay? Good? Okay. So what we are going to say? After few minutes, okay, there's heating effect. And the resistor's temperature increases. So its resistance increases. Making the power decreases due to the formula, due to okay, you can say that power equal V square over R, which is inversely with the resistance, which is inversely with the resistance. So as the resistance increases, the power what decreases. Okay, good. Any question here? Is it clear? Okay. Now what we're going to do? We're going to answer what? The multiple choice questions. Let's go back to the multiple choice questions. Okay, first question. Which one of the following, okay, drive units can be experienced by the SI unit of kilogram dot meter square per second cube? Now, it's not common, not volt, it's joule or watt. Let's check. Okay, yes, it is watt, yes, because what's watt? Watt is power, and power equal work over time, and it's force, okay, times distance over time. So it will be what? Kilogram dot meter per second square dot meter over second. So it will be -3. Yes, it's watt. Good. Okay. Next question. A wave has amplitude A and period T and wavelength lambda. Which one of the following can be used to calculate the speed? We just find it out before. It's a frequency times wavelength, so it will be wavelength divided by period, and the amplitude doesn't include in the answer. So the answer is what? D. Yes, there's no amplitude in the equation. Okay, next question. A light bulb has an efficiency of 12%. Okay, it's positioned 2 meters above a light sensor of okay, the intensity of the light, okay, sensor is 0.114 watt per meter square. Which of the following could be calculate the power of the light bulb? Okay, now the power of the light bulb, okay, we have to find how much is the power. Okay, we know that light intensity equal what? Power over area. So from this, power equal what? Light intensity multiplied by area. Okay, but they say that 12%, and they ask about the power of what? Of the bulb. So that means this power is the power output. This is the power output, not the power input. So that we know that efficiency, this is power out. Okay, efficiency equal power out over power in. They ask about the power what? In. So by doing cross switch multiplication, power in equal the power out, which is IA, divided by what? The efficiency, which is 0.12. So which one it will be the answer? The answer, it will be light intensity. Yes, this one, light intensity, multiplied by area. So the answer is D. Yes. Good. Okay, let's move on to question number 4. Question number 4, what do they ask here? A student investigates how the difference of variable effect of the speed of wave on the vibrating string. Which one of the following would increase the speed of the wave along? Now we know that speed equals square root of T over mu. Okay, so increasing the frequency, as the frequency increase, the wavelength decrease. Increasing the length of the string. As the length of the string increase, that means mass per unit length, it will decrease. Okay, but let's continue. Increases the mass per unit length, they are inversely proportional. Increases the tension, yes, increasing the tension. Increasing the tension. Now, by increasing the length, I need to also to increase the tension, right? Is it B, not D, for question 3? For question 3, it is B. Ah, yes, they give us the diameter. Ah, yes, it's areas. I'm sorry. The answer is B. My mistake. I'm sorry. Thank you. It's 4. The area, it's 4 pi r square. Okay. There's 4 here. I didn't see it. Okay. Thank you, Hamza. Let's go back to question number what? 5. What they ask. A moving electron has de Broglie wavelength of, this is the wavelength, okay? Which one of the following could be determined the speed? Okay, now we know that wavelength equal Planck constant divided by momentum. Now momentum, it's equal mass times what? The velocity, okay? So they ask about the speed or the velocity. That means the velocity equal Planck constant divided by m lambda. So Planck constant on the top, this one. Okay, the answer is A. Planck constant. So the answer is A. Okay, let's move on to question number 6. The graph shows a current versus voltage, okay, of electrical component. Which this component it tells? Who can tell which this one? This is for whom? As the voltage increases, the rate of current decreases, okay, because it's increasing. So yes, the answer is, thank you, Ammar, it's thermistor. The resistance here, it decreases. Okay, the gradient increases, but we switch the axes. Yes, so the answer here, question number 6, the answer is thermistor. If we switch current with voltage, and it will be like this way, it will be filament lamp. It will be B. The diode is not like this. The diode, there is no current. Okay. There is no current. Then suddenly it goes like this. Yes. But this is not diode. Question number 7. Which one of the following statement is correct for minimum displacement of the particle in longitudinal wave? Which one of the following statement is correct for minimum displacement of the particle in longitudinal wave? The minimum displacement, okay, the minimum displacement occurs at the compression. The minimum displacement occurs at refraction. Actually, maximum distance at compression at refraction. Minimum displacement occurs at compression and refractions. Okay, minimum displacement occurs at neither. Okay, now minimum displacement occurs at compressions and refraction. At the center of compression, at the center of refraction, there is minimum displacement. Why? Because, for example, these are the molecules, okay, when there's no sound. When there's sound, this one will stays in its position. And these molecules, they get closer. This one gets closer, this one gets closer. Okay, this one gets closer. These two also get to the other side like this. This one gets here, this one gets here, this one gets here, and these get here. So this one remains in its position here. There is no displacement. And this one also remains in its position. There is no displacement. So the answer is what? Is C. Question number 8. Energy level. They didn't ask about energy level. Okay. The diagram shows some of the energy level of hydrogen atom. Okay. Then what they ask? Okay. An excited electron at energy level here, okay, negative 45, okay, is dropped to the energy level like this here, okay, 13.6, okay. The resulting of releasing at least one photon. There's one photon is coming out. Which of the following photon energy values, okay, could not be produced from the electron emission? شايف عمار Like this question, it will take a lot of time from you to keep calculating. Okay, look what we have here. This is question number 8. We keep calculating the values. Now look here. How much is the difference between this one and this one? Okay, how much is the difference between this one and this one? How much is the difference between this one and this one? How much is the difference between this one and this one? How much is the difference between these? Okay, like this. Okay, this. You have to check if these values, okay, are equal to the differences or not. Okay, and you can see that, okay, the answer, okay, is what? Look here, 0.31. 0.31. It's from here to here. This is 0.31. So A, it's not the answer because they are not. B, 0.54. 0.54. I think 0.54 is the answer. Okay, let's go back. C, 12.09. 12.09. 12.0. This, the difference between here to here is 12.09. Okay. 13.06. 13.06. Which one of the following this answer also accepted because they didn't say that it falls from infinity. Okay, they didn't say infinity. Let's check B again. Do we have difference in energy level which is equal to 0.54? No, we don't. We don't have. Okay, Mr. From the first to the last, the difference is 13. It's how come? Ah, yes, I'm sorry. My mistake. I read the 13.6, not 13.06. So yes, correct. So the answer is what? Is B. Thank you, Karim. I read it 13.06. I read it 13.6. Okay, good. Now, question number 9. What do we have here? A pulse of ultrasound is emitted by the bottom of the bolt. The ultrasound reflected by what? By the seabed and detected by the bottom of the boat. The time is T, depends the depth D of the water under, okay, tamam. The ultrasound frequency F, the speed is V, okay, and the C. Which of the following can be used to find D? Now, D, we know that D equals speed times time over what? Over 2, right? So speed times time over 2. So the answer is what? Is C. And frequency not included. We are not going to use it. Okay, because distance here it covered twice. So speed times time divided by 2 because there is an echo. Okay. They give us the time. Right? Okay. Yes. Question number 10. Last question. Two waves leave the same source in what? In phase. The waves traveling along the different paths. Okay. Then meet. The wavelength of the wavelength is 8 centimeter. Which one of the following could constructive interference occurs when they meet? When the path difference is, of course, 16. This is the first answer. It's a multiple of 2 wavelengths. So the answer is A. But let's check. The path difference of 3 over 2 lambdas? No, it cannot be in terms of lambdas. It's supposed to be n lambda. 3 lambdas, 4 lambdas, 5 lambdas, not 3 over 2, which is 1.5 lambdas. It cannot be like this. So n plus half multiplied by lambda, it will be antiphase. The phase difference, it will be, this is antiphase 180 degrees because it's half the 360 degrees. Okay. And the phase difference is 3 radians, 3 pi radians. So we know that it's each 2 pi, it will be in phase. Okay. That means here it's a wave and a half, 1.5 lambda. Okay, so the answer is A. Okay, that's it, ya shabab. What do you think? How does glare appears for polarization? Now, glare will cut out by polarized filters. Okay, now what do we have? Let me show you. For example, there's water surface here, okay? And there's anything, for example, a fish, okay, below the water. And this is your eye, okay? This is your eye. Now, there's light that comes from the fish to your eye, okay, which is unpolarized or partially polarized, okay, unpolarized, so it can oscillate in both in vertical and horizontal. And there is light come from what? Come from the sun, okay? And what? This is from the sun. It's unpolarized, and it will be partially refract and partially what? Reflect. The one that reflects to your eye is what? Horizontally polarized. Now, when you wear the glasses, these glasses, this glass, okay, it's what? Vertically plane polarized. Vertically plane polarized. So it will cut out the one that is horizontally plane polarized and what allow the what this one only to make it what vertically plane polarized to pass. So the glare that come out from the surface of the water, that from the sun, which is horizontally plane polarized, it will cut it out so you can see the fish or under the water more clear. Okay, the glare or the blare, whatever it is. Good. Is it okay to open my microphone? Yes, of course, my Ammar. Go ahead.
Okay, sir. My question was for the last question of this paper.
The last question.
Yes, I know I have already asked you this before, but I just don't understand how the resistance can increase with temperature when also current increases with temperature.
Now we have two things. We have something called positive temperature coefficient, and we have something called negative temperature coefficient. Now, positive temperature coefficient, I'm talking about metals usually. Okay. Negative temperature coefficient, I'm talking about what? Semiconductors. Conductors. So when we talk about semiconductors, I'm talking about thermistors, I'm talking about LDR, okay, I'm talking about diodes, okay. Now, here, what do we have? As the temperature increases, the number of free electrons will what? Will increase. They will cut out their energy from their atoms. So as the number of free electrons increases, that means according to the formula Navy, okay, what will happen to the current? Increase. That means it seems that the resistance what? Decreases. That's why they call it negative temperature coefficient. But positive temperature coefficient, okay, like metals, as the temperature increases, the collisions, the vibrations, okay, of the lattice ions will what? Will increase. That means what? The collisions will what? Will increase. Okay, so the drift velocity will decrease, and due to the formula Navy, okay, that means the current will what? Will decrease. So it seems that like the resistance increases.
Okay. I understand.
Did you realize the difference?
Here, yes, I get it now. I didn't know this before. Thank you so much.
You are welcome. Any other questions? Any other questions? We are going to meet again in the 15th, inshallah, but I will add another class. I will look to my schedule, okay, and I'll send it to you. I will add another class to answer January 2020, inshallah. If you have any question, you can send it to me on privately on the WhatsApp or on the group, no problem. You are welcome, Ammar, and all of you. Assalamu alaikum wa rahmatullahi wa barakatuh. Allah Hamza. Hannah, do you have questions? Okay. Assalamu alaikum.